Hey, I'm Chris, and I'm just continuing on with my ETH Global Scaling Ethereum project. I usually do hackathons solo and just wanted to create a video of me going through one, and maybe it'll help anyone that's on the fence of joining a hackathon, especially those that are just new into software development and just learning. The Web3 community is a pretty engaging one to go through. There's just a lot of resources that you can reach out and events, and a lot of the events are also free to join, and you can also win prizes and things like that. I have done group hackathons before, and usually when you're in a group, you tend to, you know, share responsibilities and you have a common goal of what you want to achieve. When it comes to like a solo hackathon, my usual mindset is because I'm going in there with a purpose of wanting to learn something new. And for this one, I'm intrigued about learning more about Nillion. They just came onto the scene recently. I previously have been focused on zero knowledge, and Nillion's more on the MPC multi-party compute side of things. And the use cases I've been building projects around are related to healthcare. And in this one, we'll go through kind of what I'm envisioning. So yeah, we'll just get started. So the last part where I left off was going through the Nillion documentation, just basically going through their what they are and their quick start, their mini program. And they utilize a program or their language called Nada. And yeah, that's what I went through so far. And it seems to have what I want or what I'm looking for in trying to build this idea. And, I'll kind of sketch it out here. All right, so let's just take a look at what we want to achieve for this project. The goal is demonstrate a program to take a patient data and run computations through multiple data sets. I mean, the idea is the multiple data sets are basically like your different health networks. So to kind of give a visual of what I'm wanting to do, if we, in healthcare, we have healthcare provider network. Figure out the spacing. It's first time using eraser, but the Miro board shows the spacing, but it's all right. 3 healthcare networks. Maybe it'll be better to showcase it here. And it should have the patient, person, user. That works. Can I group this? Group. Sweet. So we have the patient's data and normally how it works is the patient's data, your care is the quality of care that you receive is usually dependent on the healthcare provider that you're on. Where AI is going, and we can see how much important data is, and it'd be nice to always have a shared central database that allows anyone to participate, to run analytics, whatever it's needed basically. But that might not be the case when you're comparing a health provider in network A versus network B or C. So it would be great to demonstrate where we can show how a patient's data utilizing Nillion. So I should probably write Nillion here. one of the toughest things in healthcare is transferring data. And that's one of the reasons why they created, or there's this organization called FIRE. Efficient transfer and, efficient and secure transferring of data is one of the reasons that, keeps healthcare, from really being open. So let's think of some requirements. I like to try to use like realistic healthcare data samples. It's one thing to just create a healthcare project, but it's a whole new world when you start thinking about what type of schemas that is being utilized. This is where, I'm for this type of specification, the fast healthcare interoperability resources. By learning about just what the standards are in healthcare, it really helps your project to stand out, at least in my eyes, having worked in healthcare. If just using simple JSON objects as like your sample data, it's great to see, but it's really just a labeling your project as something healthcare, but you have to really do more. And that's where these standards come into play. So I'm probably going to try and do something if I can find like, topic cancer research. Maybe there's statistics on why don't we look for some right now? Let's see. So we have diagnostic data for breast cancer from Wisconsin. Features are computed from digitized image of a fine needle, aspirate FNA of a breast mass. They describe characteristics of the cell nuclei present in the image. A few of the images can be found here on the Wisconsin website. Separating plane described above was obtained using a multi-surface method, MSMT. Decision tree construction via linear programming. So the variable names here, this might be something I can use. Let's see what we can do. All right, here's an update to my diagram that I want to do for the project. The goal is to find a realistic database that I can, do some computations off of. On Kaggle, we have a data set here that's focused on breast cancer, Wisconsin, and we will utilize this repository from UCI machine learning. And what I'm looking for is a data set that can just help us simply provide a target. And that's what we have here. So, each row sample has an ID and they have a diagnosis field. And we can use this here. So it's basically M for malignant, B for benign. And then there's all these, data points that we can utilize to run a test patient. So I think if we go ahead and utilize this data set here, we'll go to the actual repo. And what I'm going to use is Google Colab because in this UCIML repo, we can see here that it allows us to utilize Jupyter Notebook. And so So here's our Google Colab, our Jupyter notebook. And what we want to do is install this repo using the Python command. So while we're installing that repo, there's also a command to wrap the text. What I found was in the Jupyter notebooks, there's not a simple way, or I don't know, to wrap the text. You'll see what I mean. So we'll just take this line. We'll add code here, run this here, and then add another line. And so if we look at example usage here that they have, we can just simply run this. So they have fetch command and a list of available data sets. So we can see actually here, there's quite a lot that's available from this UCIML repo. And in this example for the heart disease, the ID would be number 45. And we can actually access the metadata from, that data set, and that's printed out here. So we can see, if we keep scrolling, we see 45 for the ID for the heart disease. The number of instances in this data set is 303. And we have the info or the summary on this. The database contains 76 attributes, all published experience referred to using a subset, 14 of them. The Cleveland database is the only one that's been used by ML researchers. The goal field, that would be number 13. The num field is the target. And what this represents is based on the attributes ran. If the value is 1, 2, 3, 4, it distinguished presence. And if there's a value of 0, then that target is absence. So this is something that I could probably utilize as well in the project. So this one has 300 instance. And the other one that I was looking into, so if we create another code for the breast cancer data. So I have a modified version of the code that I just ran. I'm just going to comment out the listing of all the data sets. And what I'll do though is so if we go to the breast cancer one here, it's using ID 17. The X and Y features and targets. So it's the same thing. I'll just go ahead and replace all this with the variable name here. So I will be printing out here's what's available in the metadata. All right, here's the metadata. So we'll take a look at this data set for the breast cancer Wisconsin diagnostics, the ID. I don't think there's anything in the task when I ran this earlier. Oh, the repository URL, the data, the raw data URL, the instance in this data set, and then the summary. Oh, let me run it again. I missed one. Oops. All right, so let's just read through. So the ID for this data set from this repo is 17, and then the URL of this repo is here. Okay, so we've seen that. Then the raw data is found here. There's 569 instance sample data that we can use for the project. You know, what we can utilize on this is we can see the attributes. Can I scroll? Yep. So here's 32 attributes, and number one, row 2 will be the target, and that will contain the result, which is basically going to be M for malignant and B for benign. As you can see, there's no missing values from this. So we can take a look at the raw data. Actually saved it down. So here's that data set here. No, probably not a good idea to zoom out. Here's the data set. So the attributes, we have an ID, each one will represent. We can utilize patient data or an image, and then the parameters of the image. And then at the very end, we have the diagnosis. So M for malignant, B for benign. So that's what we will utilize for this breast cancer data set. And again, going back to our diagram, you know, the goal will be able to keep this data set complete, minus a few instances that we use for running the computational tests through the Nillion network. But we expect that when we run the patient or the image through the data set, we should arrive at the same diagnosis. And then what we can do is split up the data set. You know, I'm thinking about 30% will go to a healthcare provider network C, and then the rest will be representing a healthcare network provider labeled B. And you know what I could potentially try to do is get 30% of the data, so it will you know, it will produce maybe some expected results that's going to differ than running it on a full data set. So basically just figure out which ones to choose. But then the rest of the data will then be put in here. I'm not really sure what the value will come out there, but one of the tests that I do want to be able to do is showcase where you run that patient on both of these dataset combined, and you should arrive at the same target value as the completed dataset here. And by doing so, when we get to run on the combined datasets through Nillion network, it's doing it in a way where, for one, the patient's data can remain encrypted, and then each of these datasets here are also encrypted. So, nothing is really revealed, to between these healthcare providers. So that's the goal to achieve here. And yeah, we'll see how that goes. So keep following along.